Analysis and design of retaining wall require checking the stability due to many risks. A retaining wall may fail in any of the following ways. It may overturn about its two. Let us see this figure. Here, an example of cantilever retaining wall subjected to earth pressure, lateral earth pressure, which may make the retaining wall overturn about the point at the two. This is the two of the retaining wall, and this point is the heel of the retaining wall. So we have to check the stability and the factor of safety against overturning. As the weight of the structure of the retaining wall increases, the stability increases. The factor of safety against overturning increases, since it gives us a moment around this point which resists the applied moment. The second case is the sliding. We have to compute the factor of safety against the sliding. As the friction between the base of the retaining wall and the soil increases, the factor of safety against the sliding increases also. The third case is the loss of the bearing capacity. The soil under the base of the retaining wall may be not sufficient to carry the vertical loads come from the retaining wall. So we have to compute the ultimate bearing capacity here, the ultimate bearing capacity of the soil, by a different equation that we have learned in the first course, and get the safety factor against the applied pressure. The load comes from the retaining structure, retaining wall, causes non-uniform distribution under the base of the retaining wall, and so we have to divide the ultimate bearing capacity over the maximum stress here, and get the factor of safety to check the ultimate bearing capacity. The fourth case is the excessive settlement and the deep-seated shear failure. The shear failure may be start from this point, and all of this wedge of the soil is filled, and we may use light backfill so that the soil under the base of the foundation can resist the high load applied and comes from the retaining wall. Also, we have to check if there is a weak layer in the depth of about 1.5 B. B is the width of the base of retaining wall. We have to check if there is a weak layer here, since this weak layer may cause excessive settlement and make the retaining wall fails.